All right, am I audible to Anisa, Oishi, Safrina, Vansh?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. So, see, class, we have to start with electric field, the whole concept of electric field. Let us discuss this. See, electric field is what basically, let's say we have a charge. This is what? This is a stationary charge. Stationary charge, okay? And what do? I bring one more charge, okay? And what is this? This is the test charge. Why test charge? Because this will help me decide whether there is a force between plus q and small q or not. Now what do? I bring this minus q further. Then I bring this further. I'm noticing when I'm putting it here, there is nothing which I'm able to experience. No electrostatic force, neither attraction nor repulsion, or even let me change the sign. Let's say this is positive only. Still, at least it should repel it. So see, besides every individual charge, there is a space which we called as electric field. If I'll put it here also, no, I'll not be able to experience any forces of attraction or repulsion. As soon as I bring it here, I will be able to experience the forces of repulsion. So whatever the force this test charge is experiencing, we'll be able to detect when it has entered the space. And this space is nothing but the electric field. Around every charge, you have a space where electrical properties can be experienced, okay? And basically, see, this is used to explain all the non-contact terms. Because your Coulomb's law, when it is used, the charges are not brought in contact to each other. It's unlike the charging of conduction. So all these are to explain the non-contact concept of forces. Okay. So an electric field is said to exist at a point if force of electrical origin is exerted on a stationary charged body placed at that point. And the space around this charge where you can, this is the easiest definition which you can understand. Space around a charge where you can experience electrical properties. So it's like magnets are better to be understood this way. When we have magnets, at least all of you must have experienced when two magnets are brought. They can either repel each other or attract. So within a certain limit only. You cannot put two magnets here and expect them to show magnetic properties. Similar is the case of charge. It's just that charges are not visible to us. So that's why this whole concept is a hidden concept. But all these things exist. And see, to explain non-contact forces, we require the concept of field. So it's a property of a single charge. See, when we discussed Coulomb's law, in Coulomb's law, I had always taken plus Q1 and plus Q. Means any plus is not a compulsion, minus is also there, but two charges were necessary between the two charges, a separation. But that's why the formula also had 1 over 4 pi epsilon naught Q1 into Q2 by R square. Q1 is also there, Q2 is also there. Presence of two charges is mandatory to apply the Coulomb's law. But when we talk about the electric field, if I just have one single charge here, it needs to have its own field around it. So that's it. Individual monopoles have their own charge, own electric field. Okay. So it's a property of a single charge. Even if you have one single charge, it will experience the electric field. This will have all of its electric field line. And these electric field lines, they travel with the speed of light. This concept we'll see in the chapter EM waves also, electromagnetic waves. There, this point will come again. Electric field travels with the speed of light, and the speed of light is 3 into 10 to the power 8 meter per second. Now, what is its value? This was all the theory part. Class, one thing, please stop me or just ask whatever doubts you have in between. Okay, you can always interrupt, ask, use the chat box or anything. If you want me to repeat or stop or go slow, please let me know. Because we are starting from the first chapter and lots of chapters are there. That's why I'm just discussing things and asking you to take the screenshots of the theoretical part. I hope you all are writing them in the registers, or the screenshots are just kept and taken. Are you people writing? Yes or no? लिखा है किसी ने? बस स्क्रीनशॉट लेकर रखा हुआ है. You are writing. What about others? Anisa, did you write all the notes?
Yes.
Oishi. Okay. Oishi, what about you? Have you written? Vansh?
I've written some.
Okay. Vansh, what about you? सारे नोट्स लिखे हैं वंश अभी तक जितने कराए हैं? Yes, Vansh, you there? Vansh, are you present in the class? Are you listening? Oishi, whatever notes are left, try to complete that also, because this will go a little fast, okay?
Okay,
All right,
ma'am.
Vansh, you need to respond. Text me in the chat column. Meanwhile, I'm starting. Okay, when we talk about the electric field intensity, okay, you are unable to unmute yourself. Okay, no problem. You can use the chat box. I'll read the chat. Yeah, electric field strength, intensity, electric flux density, lots of terms are there. Which is the common term for you? Electric field strength and electric field intensity. Electric flux density is not usually used now for the electric field. You use electric field strength, electric field intensity. Now see, this is the source charge, which is which is stationary. Now, why am I calling it as the source charge? Because we are studying its electric field. It is the source of creating the electric field. Basically, electric field is there around this charge. So that's why we are calling this as the source charge. And we are just using this to test it. But one more thing, class. This is also charge only. It should have its own field around itself. And these fields should at a distance repel each other, and our experiment should have been directly zero. We would never have been able to reach the result. Then why are we neglecting this? Reason is that we choose a condition that is electric force. When we write the electric force is there's a concept of electric force and a concept of electric field. So we say electric field is equal to limit Q tends to zero force by the charge. Now see, what is this? What is the meaning of this? Look, if I consider its electric field, that will hamper our result. We'll not be able to get, and it's a charge. Every charge has its own electric field, so this will also have its own electric field. What we do, if we reduce its magnitude very, 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 very less, if the magnitude of this charge, small q, if I make it very, 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 very small, almost tending to zero, but not zero. Zero charge means nothing. You don't have anything. But a very, very, very small value, almost tending to zero. So this means Q tends to zero. Tends to zero means that it is tending to zero. It is not zero. It is almost reaching zero. Okay. Q tends to zero. So what happens is its magnitude is so less that whatever is the electric field, that will also be very less. So that won't affect our experiment. Okay. So that's why we write this. Usually we can straight away write the formula of the electric field as force divided by the charge, and vice versa also, force is equal to electric field into the charge. This formula F is equal to QE is used often even in the magnetics chapter. Safrina, Anisa, you both did also. Remember electric field. So force is equal to Q into E. Now if I write the value of this charge as 1 coulomb, 1 coulomb I'm taking. So can anyone tell me what will be left in this formula? If Q's value is 1 coulomb, what will be left?
F is equals to E.
Yes, very good. F is equal to E. When Q is equal to 0, see why did we do that? Just to make a definition. See, can I now say after this discussion that electric field is basically the force experienced by what? By a unit positive test charge. Right? This is unit positive. When we make this value as unit, unit means 1. Unity means 1. So unit means 1. Positive, definitely we have taken. So electric field is basically the force experienced by unit positive test charge. So this is one more definition of electric field and one more formula. Now, this is what I was discussing with you. Limit Q tends to 0 means force experienced by Q is negligible. And that's why capital Q cannot move. Otherwise, if this also had its electric field, this would have moved, this would have moved. You don't have a stable system. So this condition is taken in physics. Electric field is a vector quantity, so all the vector laws will still be applied. Like electric force, electric field, vector laws will be applied. Direction of the force, direction of electric field is force experienced by the test charge. This will be a little clear when we do the electric field lines. I'll tell you this thing later. Unit. 2 units are there, class. From this chapter, the unit is Newton per coulomb. See, force divided by charge. This is Newton, this is coulomb. And from your potential chapter, the formula, the unit is volt per meter. Okay, Newton per coulomb or volt per meter. In this chapter, we use this, but see, you don't have single chapter coming in the exam. When you will have the exam, both the chapters will always be there together, whether it's any exam. So remember both the units. Okay, and this is what I was saying. Electric field at a point can also be defined as forced experience by unit positive test charge. A very easy formula based question I'm going to discuss, but before that, tell me, have you all understood the whole concept of electric field?
Yes.
All right. Yes. Anisa, what about you? Are you getting?
Yes, ma'am.
All right. Please respond, Anisa. Start responding so that I also get an idea how much you're understanding. Okay. And one same with you. You can type if you are unable to unmute yourself. Just type, but respond with things and if you have any doubts. So see, for this, I suggest just take the screenshot so that we do not just stay on this chapter. We are able to complete a major portion today. Numerical, I'll discuss with you. So this you can take the screenshot later. Let me discuss the numerical, then this topic will be over and we'll move on to the next topic. See, this says that a test charge of 10 to the power minus 3 coulomb is there. It experiences a force of 10 to the power 2 Newton. Force is given. It says what's the magnitude of electric field. So we know the formula. Electric field is force divided by the charge. Electric field will be 10 to the power 2 divided by 10 to the power minus 3. When this goes up, minus will become plus. So that makes it 10 to the power 5 Newton per coulomb. You don't need to put the direction right now because question said only the magnitude. But remember, it's a vector, so you'll always have to specify the direction. This derivation we will do later, but you all just take the screenshots. And if anyone has any problem with the screenshot thing and you want to write in the class only, just let me know, whatever your views are. Because this is the first chapter and it's very, very, very late for chapter 1. But you all haven't done chapter 1 with me. So that's why I'm discussing this chapter. Okay? Please take the screenshot. Oishi, are you referring to the assignment or the
Yes,
test
ma'am.
paper? Assignment, no? Yes, yes,
The
assignment I'll
assignment.
discuss in today's class. Yes. This you all copied down in the notebook. I think by now everybody has completed the writing. Okay, let's move on to the derivation of electric fields formula for a point charge. Like F is equal to the Coulomb's law formula that we use. Similarly, for electric field also, we should have a formula for point charge. Like if I give you a charge. Yes. Somebody says. Anisa, okay, my mic is on. Are you asking Anisa anything?
No, ma'am.
All right. Okay, so these are the two charges. This is the separation between them as R. Now, yes, anyone. Okay, Anisa, let's start with you only. Tell me what's the force between them? Like Coulomb's law. Yeah, Anisa?
K Q1 Q2 by R square.
Very good. This is K. Q1 is small q. Q2 is capital Q here divided by R square is a formula. Okay. The Coulomb's law. Very good. Now see, when we write down the formula of them, now when we talk about the electric field is basically force divided by the test charge. Now when I put the value of this force here, electric field will be equal to K small q capital Q divided by Q into R square. Q gets cancelled. Electric field is equal to KQ by R square. That's it. Okay. Or if we want, we can write it as, yes, once, what is the value of K? What's the formula of K? Yes, one. Formula of K. From here, the settings, you all can unmute yourself. Type the answer then once if you are unable to unmute. Okay, you are able to unmute. Okay, yes. Value of K?
9 into 10.
9 into 10?
9 into 10 to the power 9, I guess.
Don't guess it. Remember it confidently. Yes, you're right. 9 into 10 to the power 9. Okay. But what is the formula of it in which we get it? K is what? I'm not asking the value. What are the... I'm asking you the formula of K, not the value of the K. Was there any epsilon naught there? Something you can now recall once? Value of K?
Something like 1 by 4 pi epsilon naught.
Okay, one thing before we go further. Once, are you not revising whatever has been taught in the class?
I'm revising.
You're revising. So this is the very, very, very basic part. So please revise it again so that you are confident. See, your answers aren't incorrect, but you have to be confident. You can't guess 9 into 10 to the power 9 something, or maybe 1 by 4 pi epsilon naught something. Please revise properly. And if you have any trouble, then let me know. I'll help you with it. And these are very basic things. Okay. So just revise them once again. So it's sure. Okay.
Yes, ma'am.
So this becomes Q square by 4 pi epsilon naught R square. This is the formula of the electric field for a point charge. Like we have the Coulomb's law, this is the electric field. Now for the direction, this is what I was telling you. Remember, if there is a positive charge like this one, wherever your point is, just move away from that charge. That's the solution to remember it. Like this is point A. I have to get the value of I have to get the direction of electric field. So I'll move away from this like this. Positive, move away from the charge. This is the B point. Move away from the charge. C point, move away. D point, move away. When you have a negative charge, then from the point, move towards the charge. Like if this is my A point, I'll move from this point, I'll pick it and move it towards this minus. Electric field will be directed like, all these are what? What are these arrows that I'm drawing? All these are the direction of electric field. Now in Coulomb's law, I discussed this part already in detail, that when you have epsilon naught, when the medium is changed, what to do. Same thing will be applied here also. 1 over 4 pi epsilon naught Q by R square. Epsilon naught is for air. Epsilon you will put for medium. And these things we have already studied. K epsilon naught is equal to epsilon. So electric field in medium is air by K. Like this. We already did for force. Remember the formula of the force was force in the medium is equal to force in air divided by K. It's the same thing, class. Okay. One small easy numerical let me discuss. This once came in your 2-mark questions of your board exams. This says that a point touch figure wasn't given. A point charge of 10 coulomb at origin is kept. Means it is kept at the origin. You have to calculate the electric field at a point. 3, 0, 0. See, when I say A is at any point is 3, 0, 0. So this gives me an idea that this is the x-axis part, this is the y-axis part, and this is the z-axis. So this clearly tells me the position of the point A, so that I can mark it here. Now, A is, if you see, this is 10 coulomb kept at the origin. This has the value 3. Okay, it means this is 3. Y0, Z0. So no need to put anything. It means this is separated to 3 meter from here. So when we put in the formula, E is equal to KQ square by R square, KQ by R square. So K is 9 into 10 to the power 9. Charge is given as 10 R square. 3 square is 9. That becomes 10 to the power 10. But see, if when this is 10 to the power 10, now we cannot answer like this. Magnitude and direction wasn't a part of your board's question. Question was from here to here. Magnitude and direction, I have written that whenever you answer vectors, magnitude and direction should be written properly. Now, this is a positive charge. So, Safrina, you tell me from this point A, where should the electric field be directed? It's a positive charge.
Away.
Away. Very good. So see, if I move like this, so this will be towards the charge. So I have to move in the opposite direction. That is this. Now, it was given already that these are axes. This was our x-axis because here 3 was at the x-axis. It means this is our positive x-axis. So we can write the direction as 10 to the power 10 I cap Newton per coulomb as our final answer. Got this, all of you?
Yes.
Yes,
All right then. Take the screenshot of the above, write this, and then we'll do superposition principle in electric field. This has come recently a lot. Just take the screenshot from here. Let me shut my video. Take the screenshot. Copy down this one. I hope you leave spaces while writing the questions. Coming to the superposition principle, some a part of superposition principle we've already studied in the electric forces. Okay, so now for the electric field, it's the same thing, class C. If you have multiple charges and you have to calculate the net electric field at a point, then what you have to do? So see, let's say we have Q1 as a charge. This is a point P. Separation to this charge is R1. Okay. Similarly, this is another charge Q2. Separation to this point is R2. Like this, many charges are there. So what I'll do, superposition principle says that first you calculate its individual quantity. Like electric field 1 will be KQ1 by R1 square. Second electric field will be KQ2 by R2 square. Third one will be KQ3 by R3 square. Like this will go on for nth. This will be KQnth by Rnth square for whatever number of charges are there. And what you do? Finally, you take the net value as E1 plus E2 plus E3 plus E4 plus E5 up till Enth. And when I say you are adding them, doesn't mean you're actually just adding them. This means this is a vector addition. This is the vector addition. So that what has been written for a system having n interacting point charges. Net electric field at a point is the vector sum of field due to individual charges. Due to individual charges, whatever electric fields are there, then for the net one you add them vectorically. Now the concept of neutral point in electric field. This will be a little simpler. And I think one of the questions, Vaishi, in which you did not attempt well was this only from the force, but similar to this. So you'll be able to understand it better. Oishi, was it you or some other child who has written 4 by x square, 1 by a minus x square, and instead of taking the root, you have actually multiplied and used? Have you done that?
Yeah. I didn't
Okay.
forgot about that.
See, Oishi, no need to do that.
Yeah, we can just root both sides. Yeah, I
Yeah,
got that.
root on both the sides. Okay, I wrote in your sheet so that you put that here. So see, let's discuss neutral point. Means the net electric field or net electric force is zero at the point. Like if I have this, let's say two charges are there. One is Q1, another is Q2, whatever is it, and I'm calculating the net electric field at the midpoint due to this and due to this. Neutral point basically says that the net electric field is zero. This electric field 2, electric field 1 will balance themselves. And not just electric field, for the forces also. But this point is termed as the neutral point. Okay. Point at which electric field of individual charges cancel each other. Cancel each other, when will they cancel? When they are equal. Now, based on this, we'll practice a question. Two charges plus E and plus 4E are placed at a separation A. Okay, let's say this is plus E and this is plus 4E and they are placed at a separation A. Now, this says at what point on the line joining the two charges net field is zero. Now, do we know the point? We don't know because that's what we have to calculate. Let's say here is the charge. Okay, at not the charge, sorry, here is the neutral point. So if this is the neutral point, it means electric field due to this and electric field due to this will cancel. First, we need to find the direction. See, let's say this is A point, this is N, this is B. Due to A, electric field will be away. So this is EA. Due to B, electric field will be towards, this is EB. Okay. A away for this, B. So now one thing we know, if they are balancing at the neutral point, electric field at A and electric field will at B will be. That's it. Let's do one thing. Let's say neutral point is at a distance of x from plus E. So what will be left here? A minus x. Okay. Now just putting of the values. Yes, Oishi, you are left to answer. Tell me EA value. This EA means plus E. So what is the electric field? electric field for a point charge is kq by r square. Yeah, now tell me. What's it come for? See, this is the charge. This is the point n where we are calculating. Try at least.
Yeah. So K E by x square.
Yes, ke by x square. We only take the magnitude. Very good. And Noshi, for this one?
And K 4KE by A minus x the whole square.
Very good. Exactly. Now see, ke will be cancelled, and I think this is a similar situation which we are discussing. So you take the root. That makes it 1 by x, which is 2 by a minus x. Now you cross multiply them. This becomes 2x is equal to a minus x. A is equal to 3x. So x is equal to a by 3. Now see, if x is a by 3, it means our answer is a by 3 from plus e. So you have to mention from which chart, because x could be anything. If the question said tell us the neutral point from plus 4e, then what you would have done? Either you would have taken this as x, or you can just simply subtract a minus a by 3. That makes it 3a by 3, 2a by 3. So you can say 2a by 3 from 2a by 3 from plus 4. That's how we solve these neutral cases. Is this question clear? Okay. Take a screenshot of this and write the question, okay? Okay, now note down the question. Done. Yes, Soishi. I'll be discussing the assignment. Don't worry. I'll discuss the entire assignment. No need to copy paste. I know the questions. Okay. I'll share it. I'll discuss. I was just waiting for a topic to be completed. Okay. After that, I'll discuss.
Okay, ma'am.
Okay. See, basically, in this question, there's one thing that we should know, which I'll mention you, which we didn't discuss in the class. Let me just complete this part. Before the dipole, I'll definitely discuss. In fact, I think we are just almost towards the end. I'll discuss after this. Okay. See, when you have symmetrical figures class, like a line where two charges are present and the charges should be identical to themselves. If this is plus q, this is plus q, not minus q, not 2q, not 3q, not minus 3q. Identical means exactly the same. So when we say symmetrical system first, the symmetrical system first condition is identical charges. So net the neutral point for electric field, whether electric field or electric force, it is given at the symmetrical point of the system. Like for 2 point charges, it will be given at the center. For you increase the sides, triangle at the centroid of the triangle, rectangle at the center, square at the center. You increase the side, pentagon, hexagon, like this you will get, but all the charges should be the same. Eventually, it will turn into a circle where the net force, net electric field is 0. Now, this is a question based on the superposition principle. So let me just discuss this with you. Okay, class. 4 charges are there. Let's say this is A, this is B, this is C, this is D. And at the center O, we have to calculate the net electric field. Okay. Safrina, you tell me, due to A, at this point, where should the electric field be directed? Direction क्या होगी यहाँ पे? This is the charge. This is the point.
Ma'am, from O.
From O to where? OA.
Ma'am, no, ma'am. From O to. You're asking the direction from O.
Yes, from O. Yes, I'm asking the direction from O. Because this is the point of calculation, no?
Yeah. So O to A.
O to A. If I draw it like this is what you're saying?
Sorry, ma'am. It's away. So it's towards C.
O to C, yes. OC. Correct. See, this is the direction of electric field due to A point, E. Because positive charge is there, so away from the charge. Oishi, tell me for the B part, at point A, where should it be directed?
D.
What?
OD.
OD. Perfect. This is also positive charge. So from this point, just move away from the charge. So when you move away from the charge, this is EB. Okay. Yes, Anisa, tell me for the C point. Yeah, Anisa. Once, can you try?
I'm not sure.
Okay. Anisa, yes, you're answering.
Ma'am, I'm not sure.
Okay, what did we study, Anisa? See that the direction of electric field for a negative charge. Is this positive? At C, what is the charge? Tell me. At C point, what charge is there? Anisa, you
-2.
have to, yeah, -2, exactly. So it is negative.
Yes, ma'am.
What did we study for negative? Towards or away? Look into the notes, Anisa. You must have written towards the charge or away from the charge. Anisha, did you take the screenshots? Check from there. What have you? All at once, can you tell?
Is it
Direction
towards?
towards. It is towards. So which direction? O point is here. Now you tell me, where should I put the arrows like I've put for E and EB? This is the negative charge. It's a very common question, that these questions are very common. Yeah. So towards what? Where should I write? I'm here at this point center O. Yes, one should at least try. You are right. Towards is correct. Okay. So now move towards. Tell me towards what? Like the other students answered. Towards A, towards B, O to A, O to B, O to C, O to D. What do you think?
Is it 4 to 8?
Okay. How is this towards the charge?
Sorry, 4 to C.
O to C. See, if you have taken already on this axis, doesn't mean you cannot take it again on the same axis. Rule is rule. If it is repeating, it will overlap. But our rule says that we have to move towards the charge. So yes, you are absolutely right. This is easy. Very good. Anisa, now did you understand?
Yes, ma'am.
So tell me for the D point. Now you tell it from your end.
So, ma'am, it goes towards D minus Q.
Yes,
O
minus
to
Q,
D.
so O to D. Very good. Got it? So like this, you have to identify. So this will be E, D. So all the electric fields we have written. And since this is 90 degree, 90 degree, 90 degree, this will also be 90 degree because it's a square. So perpendicular bisectors are the diagonals. Now see, if I write value of EA, charge is here, point is here. Okay? This is A, this is A. Now we need the separation of the diagonals. To calculate the values, we need the separation of the diagonals as well. So see, look at this. This is the right angle triangle. This is A, this is A. This is the diagonal AC. If we apply Pythagoras theorem here, class, we'll be able to find out about the diagonal. So diagonal AC square will be equal to under root A square plus A square, which is equal to 2A square under root, that is A root 2. But that is the complete diagonal from A to C. We don't need the complete diagonal. We just need till O point. We just need this part. If this is our O point, we just need this separation. So half of the diagonal, if this is the midpoint, we can just half it. So we can say AO is equal to BO is equal to CO is equal to DO, which is equal to A by root 2. Okay, half of it is A by root 2. How? See, if I divide it by 2, A root 2, if I divide it by 2. So to rationalize it, I have to multiply and divide it by root 2. This will make again 2, so A by root 2 will be left. So that's how this is A by 2. Complete diagonal, A root 2, half of it, A by root 2. Try to remember this because it's a very common thing that is used in the numericals of these forces as well as the field. Now see, let me write down the magnitude. EA is equal to this EA. This is the charge Q. Okay, this is the charge Q which is present, and this is the point A which is there. So we can say this is A Q by, the separation is A by root 2, so A by root 2 whole square. So root 2 means 2, that is 2KQ by A square. I hope you all are agreeing till here. I have just squared it, A by root 2 whole square. See, it will be A square by 2, 2 goes up, so this is the 2, okay? Now for the electric field B, electric field, in fact, I'll write EC together, okay? Electric field C first I'm writing. Now electric field due to the C point will be, K is there. What's the charge? 2q, not minus, because we take the magnitude. So k into 2q divided by, again, a by root 2 whole square. 2 goes up, that makes it 4kq by a square. So 2 I have written. I have written EC, I have written EA. Now let's come to EB and ED. I think it would be the same. No. This is EB, 2q. So see, EB will be equal to k 2q divided by a by root 2 whole square, which is again equal to 4kq by a square. While ED, the charge is small q, so this will be equal to kq by a by root 2 whole square, that is equal to 2kq by a square. Now see class, vectors. Two vectors in the same direction, they'll be added. So EA and EC, they will be added to get a one final resultant on this side. So we resolve this arm further. So we'll take EA plus EC, that is 2kq by a square plus 4kq by a square equal to 6kq by a square, which is pointing towards OC like this. This is the net resultant first electric field. Let's say this is our E1. Then what about the second arm? Same thing. Look here, in the second arm, EB and ED will also be added to each other. So what we'll get here, when they'll be added, we'll have EB plus ED. Again, their values were the same. So 2kq by a square plus 4kq by a square, which is equal to 6kq by a square, pointing towards OD this time. So this was E2. What am I writing? I have added these two and replaced them with a one single vector E1 towards OC. I've added them and replaced them with one single vector E2. Now E1 and E2 only I have to solve to get my resultant. Right? How do I have them? This is E1, this is E2, angle is 90 degree. Whenever two vectors make an angle 90 degree, the resultant is given by under root E1 square plus E2 square. Both the values are same. 6kq by a square, 6kq by a square. That straight away becomes 2 E1 root 2. That is E1 into root 2. What's their value? See, net electric field will be 6kq root 2 divided by a square. This is its magnitude. For the direction, you have to take the angle beta from one of them, calculate using tan beta, which I've already told in the last class. I'm not writing this. For the direction, this is the magnitude. Now tell me, did you all get this question? Yes, no? You want me to repeat a part? What?
Yes.
Okay, only Safrina Vansh got it.
Yes.
All right. Anisa, did you get the question now?
Yes, ma'am.
All right. Please copy it. Then we'll discuss the assignments. Assignments are pending, and then we'll move on to dive. Okay? Please write it. Okay, see, these were the assignments that I shared. So, Rishi has done these assignments. Safrina has given this assignment. Safrina, I think one assignment is still pending, no? Other one?
Yes, ma'am. I actually completed it. I didn't submit it.
Anisa, your assignment, how will we go with the classes, Anisa, then? See, in this question, most of the questions were easy and you all were able to do. Whichever questions I have marked. This is an important question. Just try it once. I think I didn't give this one, or was it given?
It
This
was
one.
given.
It was given. Okay. Yes. So see this because no, this involves charging by conduction. So that's why since charging by conduction is used, so we discussed it. So see before me beginning, you all tell me, is there any doubt with the questions that I have given in this one from this one, this assignment? All fine? Oishi, Safrina, I'm asking you both.
That
I think
15.
the 7th question.
7 from here.
Yeah.
Okay, this one. See, this is basically the ratio of electrostatic charge and the gravitational force only. When
Oh,
you
not this assignment. Then it's in the other one.
yes, that's what I was saying. From this assignment, because this assignment was correct. Your assignment was right. This assignment. I think this you all were able to do. Just one thing. If it comes in the board exam, no, you have to show that 1 coulomb, the charge is 1 coulomb, while the charge on the electron is this. That's why we say 1 coulomb is greater than this number. Like this, we say. Second one was Coulomb's law. Yes, from this assignment, one is 7th question. This one, and one was the last question, I think. Oishi, as far as I remember, this one.
Yes, ma'am. This one is.
Okay. Safrina, any doubts from this one? Oh, you didn't attempt it. Okay. If when you attempt, if there's any doubt, just let me know on Wednesday. See, Oishi, at least this part now would be clear that why it is 2a, 2a, 2a by 3 or 2a by 3. Any of it, this part.
Yeah, ma'am. That's clear.
And minus q and plus q, which has to be taken, that is clear. Like which should be the sign of the charge. That also we discussed. Problem must be with stable and unstable equilibrium, right? This was the
Yeah,
problem?
ma'am. Yeah.
See, this says that two charges are there. Now pay attention here, okay? And everybody, this is an important part. One charge is plus 4e, other charge is plus e. And they are separated by a distance of a. It says where should a third charge be placed so that all of them are in equilibrium. Let's say this is placed at a separation this. So we have already discussed in today's class. In fact, we have discussed. So we know which third should be placed so that all the charges in, yeah. So the same data is there which I discussed in electric field part. Now how to decide whether it's stable or unstable? See,
Ma'am,
when
also
you,
one more.
yeah.
Like if you look at the 8th question, it's asking if the system when the system is equilibrium, and in this they are only asking when the charge is in equilibrium. So how do you do the different one?
I'll tell
Is
you
there
this.
two different methods or something?
No, not two different methods. That only detects the sign for this. I'll tell you. See, this says that 2 points. Let me discuss this one, then I'll come to the next one. Okay. This says 2 point charges are there. They are separated by where should a third charge point be placed on the line joining them so that it may be in equilibrium. Now, Oishi, what it is saying, it means this new third charge that is brought, this should be in equilibrium. So you're not concerned with 4e. 4e goes to the left plus e goes to the right, wherever it moves. That doesn't affect your answer. Your this charge should be static, whether it's plus or negative. Okay. But there is one more case here, and the question I'll clarify it here. It says the entire system is in equilibrium. So here you just have to ensure the sign of this charge. That if you put it negative, is this stable? Is it not moving? Or if you put it positive, is this stable? Like in this case, I know both the charges are acceptable. Plus is also an answer, minus also an answer. Because see, Positive, both are repelling. Opposite forces, this will stay in equilibrium. Negative, both are attracting. Opposite forces stay in equilibrium. This part is correct. Is this part clear that both the charges are possible?
One more thing that 4A has a higher magnitude than E, so will it attract more or repel more?
What?
4E, it has a higher magnitude than E, right? So like
Yes.
will it attract or repel more, like the
No.
force?
That depends
No?
on the distance. Electric field, electric field or right now we're just talking about force. I'll also talk about forces. It will depend upon the distance. Let's say this is at a distance of some smaller value, say by 3, and let's say this is at a different value. So whichever is closer will have a stronger force. Imagine two charges are there. If the distance is closer, smaller, they'll attract each other quicker. Distance is more, so that depends on the distance. Where is this plus q situated from plus 4e or plus e? Definitely magnitude will affect, but magnitude helps more in the neutral point. Wherever that I'll tell you in electric field lines when we'll discuss. Wherever the charge magnitude will be lesser, the neutral point will be situated that time. So for that, the magnitude will help, but right now you just have to see the separation. If I say plus q is located here, so see, this is very closer. These two are very closer. So force will be greater. But if I say plus q is situated here, so anyways, this will be greater. Got it?
Yeah, so magnitude doesn't matter here.
Magnitude doesn't matter much. Okay,
Okay.
because usually the charges are comparable. 4e and e, they are comparable. But yes, if it's a very, very huge magnitude and it's just e here, then it can affect. Okay. Overall, we see the Coulomb's law. Ratio you will see. You will take the product of both the charges, you will apply Coulomb's law, then you can compare. Because two factors are there, no? Charges magnitude is also there and separation is also there. And they are getting divided. So you have to take the ratio. Okay.
Okay, ma'am.
Okay. Also, this part is clear that both the possibilities are there for
Yeah.
this case. Okay. Now, question says this is why it has given you so variety of options. Plus q minus q minus q plus q. Now you just have to decide when it is plus, is it stable, equilibrium, or unstable? When it is minus, is it stable or unstable? Now remember, stable equilibrium means when the charges, if you move their position a bit, they'll come back to their original position. And unstable means if you disturb the mean position, they will not come back to their original position. This is the meaning of stable and unstable. Stable means they will come back, and unstable, they'll not come back. Okay, they'll come, they'll not come back. Now, let's say this is positive charge, and I just have to focus on the plus q because it didn't say the system. So unstable means, let's check. See, if I disturb it a little from its original position, plus q is here. Okay. Now see, we'll have to compare the forces as we were discussing, Oishi. So what you see, if this force is very strong, this side of force, disturb it anywhere. When you disturb it, let's say somewhere here, randomly, you can just analyze, let's say this is some x. When you disturb its original position, if you see this force is very much greater than this will repel it. It means it will come back to its mean position. But if the force is very weak, let's say this force was very strong. Suppose this force was very strong. Okay. So what it will do? It will also, let's say the charge is here. So this force is very strong now with E. So it will push it towards the mean position. So it means positive, both are pushing it to its mean position. So for positive charge, we'll have the stable equilibrium. Because even if this is greater, it will push it towards the mean position. If this is greater, it will move it towards the mean position. So is it coming back or not? It is coming back. So stable. Got it? This part?
Yeah.
Okay. See, suppose it's negative. Now, if it is negative, you will yourself see the whole storyline will change you. If it is negative, minus q, if minus q is there, this will attract it. When it will attract it, it is moving away, further away from the mean position. It won't come back after getting attracted. Similarly, if it is negative, we have minus q anywhere here, this will attract it. Plus E will attract it. It is moving away from the mean position. It won't come back. It is not coming back. So this shows unstable. Got it?
Yeah. So negative is unstable.
Yes, that would be the answer. And because both the signs were possible. And last question, I'll just tell you a little quickly because we don't have much time, but you will be able to do it. See, when you have two spheres, two threads are there. It's like two threads are present like this. But both of them, as soon as they acquire the same charge means they repel each other. So what will happen? One will be like this, other one will be like this. Now let's see what are the forces acting. Okay, here, look, electrostatic force will be acting away. Just talk about one of them. You don't need the other one. One calculation I'm doing. Tension force will be acting along the string. And it says take the angle from the vertical as theta. So let's say we have taken from the vertical this angle as theta. So this will also be theta, alternate angles. And what else force is acting? Electrostatic force away because they have repelled away, tension acting. Gravitational force will be acting downwards, mg. Now we resolve tension. When you resolve tension, this component will be t cos theta because this is near to it. This component will be t sine theta. Now what you do for this q? See, you equate t sine theta equal to fe. Now this will be k q square by, take the separation as L square. And cos theta, t cos theta will be balancing this mg. Okay. Now the value of L is replaced by this value of the triangle. That's why you have tan and sine over here. Okay. So you take the ratio, tan will come directly, but sine is written, you take sine theta of this triangle. Because you know the length of the triangle is, let's say, some L. Length is given. This is not L then. The length of the triangle, look here. This length of the triangle is, of the string is already given to us as L. So when you resolve them, when you take the ratio, basically, t will be cancelled, sine theta by cos theta will be tan theta is equal to, you are left with k q square by whatever is this, let's say a, by a square divided by mg. You are left with this. Now see, k can be written as 1 over 4 pi epsilon naught, 4 pi epsilon naught. Okay, 1 over 4 pi epsilon naught I have written. So that's why you have these 4 pi epsilon naught here. Now for this A, what we do, see, look at this triangle, Oishi, this smaller triangle. Or I'll draw it here, in fact, this smaller triangle. If the entire separation was, let's say, a by 2, so half of it will be a by 2. Okay, length is given as L. This is what we have. Did it mention anything else? Mass is there, length meter? Yes, nothing. It hasn't mentioned anything. Now see, theta is this. If I take sine theta, I will have perpendicular upon base. What is the value of A? Sine theta into 2L. 2L sine theta. So when you square it, A square will be 4L square sine square theta. You can put it here. So from here, your Q will be equal to C. Shift every term on this side. A square, we'll write it as 4L square sine square theta. A square I've written. And tan theta is also there. Mg is also there. And this 4 pi epsilon naught is there. And this is whole under root. Okay, so when you solve it, simplify it, one of it will match. So this says q square only. So you don't have to put any under root. So which option is matching? 4L square, 4L square. Yes, this will be the option. See, Look, Oishi, 4 L square mg sin square theta tan theta 4 pi epsilon naught.
Yeah, thank you, ma'am. Thank you so much.
Did you get it? Was it too
Yeah, I got
fast?
it. No,
You
I
got
got
it?
it.
Okay.
Yeah.
So do you want to take the screenshot of the solution or you'll be able to write? What do you want? How do you want?
No, I did write a few. Like